Hi everyone, this video is an exercise 11e, the challenge question. So we want to use a substitution of the form x is equal to k sine u to show that this integral is equal to minus root 9 minus x squared over 9x plus c. Okay, so it's a good hint that we need to use x is equal to k sine u, but the only thing that we should determine is the value of k. Now, if you look at under the square root, we have 9 minus x squared. So one of the things that we should consider is that we should have a sort of substitution, because when we substitute k sine u here into x, then it will become k squared sine squared u. And since it's sine squared u and then we have a square root, so there is the possibility of simplifying because the square root of sine squared is just equal to sine. But obviously we have 9 minus that. So we can use a trick such that maybe we can have something that can easily be simplified under the square root. And one of the best options is when we have 3 sine u. So when x is equal to 3 sine u. And that's because when we square this becomes 9 sine squared u. And under the square root, then we can take a factor of 9, and then it becomes 1 minus sine squared, which essentially is equal to simply cos squared, and then the square root of cos squared is just cos. So that way, we can then simplify and get rid of the square root actually. Okay, so now let x be 3 sine u, and we first differentiate this, and this is 3 cos u, and then rearranging gives us 3 cos u du. Okay, now we substitute this here, so we have 1 and an x squared outside, which is just 9 sine squared u, and inside we have 9 minus 9 sine squared u, and we substitute 3 cos u du into the x. Okay, so we have 3 cos u, and then in the denominator we have 9 sine squared u, and inside the square root, that's what I was talking about. So we can take a factor of 9 and we get 9 times 1 minus sine squared u. And that's where the magic happens, right? Because 1 minus sine squared u is just simply cos squared, and then 9 cos squared, the square root of 9 cos squared u is simply 3 cos u. So we have 3 cos u and then 9 sine squared u times, as we said, so this gives us 3 cos u here du. And now we have a nice simplification, so 3 cos u simplifies with 3 cos u above, and we'll have 1 over 9 1 over sine squared u du. And remember that essentially sine squared u is cosec squared u. So 1 over sine squared u is cosec squared u. And cosec squared is one of the standard results that integrates to minus cot. So in this case, we'll get minus 1 over 9 cos u plus c. Okay, so now we need to remember that to give the final answer in terms of x. So first of all, remember that minus 1 over 9 cot u, so can be written as cos u over sine u, because that's just the definition of cot. And now obviously we know what to substitute into sine u, right? Because if we rearrange this, we'll have x over 3. Now we need to figure out what can be substituted into cos u in terms of x. So for this part, it's actually very easy, because we know that cos squared u plus sine squared u is equal to 1, and then cos squared u is equal to 1 minus sine squared u, so that it can be written as square root of 1 minus sine squared u. And Now sine squared u itself is the same as x squared over 9. So cos u is equal to the square root of 1 minus x squared over 9. And this can be simplified, and that is equal to root 9 minus x squared over 3. Okay, now we have everything. So we just need to substitute this into here. So finally, we have minus 1 over 9 times, so for cos u we substitute root 9 minus x squared over 3, and for the other part, which is just sine u, we substitute x over 3. But remember that we also have this value of 9 that is being multiplied. So we just need to simplify this now. So it is, so this 3 here cancels out with this 3. And we'll have root 9 minus x squared over 9x plus c. That's exactly the form we wanted to have.